Well, hello everybody, and welcome to today's webinar, CAD to Part with XiP in 30 minutes or less. My name is Sean Miley, and I'm joined by my co-host, the talented Mr. Rob Wiggins. What's up, Rob?
Hey guys.
Cool. So as you saw in the title, today we're going to, actually Rob is going to take us through a demo of the XiP platform, and he's going to show how well, let's just get into the agenda here. He's going to show how to start a print. So basically import a CAD file from his CAD platform of choice to NexaX. Then he's going to set up that his print using NexaX. He's going to export and start that print using a USB thumb drive. Then once that print is started and it's off and running, because we want to do this live print for you guys while you're here. And actually, you can see that second camera that Rob has set up, which is pretty sweet. We're not going to cut away so we can see how quickly that actually does print. And you'll see what we're going to be printing in a minute when Rob sets that up. While we're waiting for it to print, I should say, we're going to go through some of the features of XiP. And so we'll take a deeper dive into NexaX software, all the features within that window, and then we will talk about the top 8 features of XiP as well. And then, of course, we'll do the reveal. Hopefully, that print will be finished, and we'll show how that came out, and then we'll get to a Q&A. Which reminds me, if you do have any questions throughout today's webinar, please drop them into the Q&A feature of Zoom, or you can drop them into the chat as well, and we'll try to get to as many of those as we can. So without further ado, I'm going to go ahead and stop sharing my screen, and I'll turn it over to you, Rob.
All right. Hey everybody, I'm Rob Wiggins. I'm the head of creative services here at Nexa. Before that, I used to work with Hasbro. I've worked in the film industry, doing props and different things like that. I'm happy to be here now, and I'm happy to show you what the XiP really can do. And one of the whole reasons that we came up with this is because so many times, so many people say, oh, well, we can print this and this time, we can print that and that time. And I feel like proof is in the pudding. So that's what we're here to do today. We're going to show you just how fast the XiP is and what separates it from every other 3D printer. Because anybody who does 3D printing knows how long things take. So we don't want that. All right, so to start things off, I'm going to show you how I import a file into our 3D prep software, NexaX. And I'm going to be taking that from my CAD software that I'm using. Of course, you can use any CAD software, the CAD software of your choice. Today, what I'm going to be showing you when I share my screen is just what I'm using today. I use so many different things, but just for today and just for the piece that we're printing out today, I'm using ZBrush. Don't know if you've heard of that before, but ZBrush is a great program, especially also it's good for prepping 3D prints. So let's jump right in. I'm going to share my screen with you guys so you can just see what I'm about to get into. All right, so here in ZBrush, this is the file that we're going to be using. This is our new and improved XRook, specific just to Nexa 3D. Many people have heard of or seen the Rook. It's kind of been like an iconic piece that's used in every kind of 3D printing company. Has printed a Rook as kind of a stress test for their printer, whether it be FDM, SLA, or the like. But with this, it's got many different fine features on it. Like we've got the mesh walls. If you zoom in a bit, you can see that we also have a lot of fine details going around into the base. But the XiP will pick all of this up, and all of this is going to be unsupported. So we're super excited to get this print out. So what I'm going to do in this is I'm going to export this file out, and natively it exports out as OBJ. I kind of find that file format to be a little bit better than STL, just because if you're working in a team, sometimes people have different, CAD software, just different, ways that they have their setup as far as their operating system and things like that. And OBJ tends to be a little bit more stable when you're sending those files to different computers. Whereas the STL doesn't have any file size information, but the OBJs do. So that's why I like to use that. So I'm just going to save this to my desktop. And then I'm going to open up the NexaX software, and then I'll share my screen with you once I have that open. Okay, so here we are in NexaX. We set our printer to the zip. The resin material that we're going to be using today is our X45 natural. The layer height we're going to use is 200 micron. Keep in mind, 100 micron is the size of a human hair. So 200 micron will be fine to pick up the details that we need. So I'm going to hit apply, and then I'm going to hit import. So I'm going to import that model. There's X45 natural. As you can see, I got a whole bunch of different files here. I probably should have placed that better. You ever get into that situation where you put something in here and you're like, where did I put that?
All the
Okay, here we go. All right. So NexaX is going to check for water tightness, and it's going to bring the file in. So here we have the file. So this is going to be printed without supports. So it needs to be oriented correctly. So there's a lot of tools that we have here in NexaX to do something like that. If you click on the transform tab, there's a couple of ways that we can orient this part. I'm just going to use this orient to base tool because it's a lot quicker. So you click on that, and then you aim that here to where you want the print to point down toward the base. And as you see, it prints it directly to the base. All done with that. Now, while I have it here in NexaX, just like with any other software, there's going to be plenty of ways that you can move this file around. You've got translate, rotate, scale, and duplicate here on this side, as well as manipulating the slicer to kind of go through the print and see how it's going to print each layer. Now, rather than kind of move this all around and duplicate it and then have to go in and kind of like move things around to where I think they're going to be, the great thing that I love about NexaX is it has an array feature. So we're not going to just print this one. We're going to print a whole build plate of these X rooks. So I'm going to take you into the array feature and how I get that done. Right here on the left-hand side, you've got, again, you have transform, support, edit, array duplication. You also got analyze. Here, this is a feature where you can actually go in. I'm going to click on it, and you get a measuring tool. So if you're ever wondering, what's the size on this piece? All right, so at the base here to the top of the crown part is 36.88 millimeters. So it's measuring parts of the print using these two points. So you can change that around just if you're curious about, the size of things on the prints that you're using. I just want to show you that too, just because it was a little cool feature. But let's get to array duplication. I'm going to go to the top view just so I get a good view of my part. And then I'm going to lay this out after I select it. Okay, array duplication. All right, so I'm going to put a whole build plate of these. In the Y, I'm going to put 3 more. And then in the X, I'm going to put a row of 5. So this is how you can get that done. And I'm going to space these out a little bit more. I want these to be buttoned up against each other. So it's getting a little slower because the scene is getting really heavy with all of these rooks. Okay, I'm going to accept that. Total count is 15. I don't like that this is kind of towards the edge, so I'm going to grab all, and then I'm going to move it over just slightly, just to make sure it's pretty much in the middle of the build plate. Okay. And once I have that set up, I'm going to save this file to my USB. Now, with NexaX, you'll be able to actually send this print off via Wi-Fi or Ethernet to the zip. But I'm using the USB because the area in which I'm working, I'm not connected via Wi-Fi to these printers. So I'm just going to use my USB instead. So I'm going to go down to the Save tab, Save Job. I'm going to save this as X45 natural space test. And once you hit save, it's going to go through slicing.
Got a couple questions for
Yeah,
you.
go ahead.
While we wait. Somebody asked how much spacing is required for duplication.
It's a good idea to give yourself or give the parts some room whenever you're doing the duplication process. You don't want things to be too close, because if they're too close, they may intersect. But the software NexaX will actually tell you. So I've never run into a situation where I've done a duplication and a part printed over top of another one, because NexaX will send up a warning for you. So it's not likely to happen.
So you're just being a little extra conservative by adding extra space, but automatically should have enough space theoretically.
Yeah.
Okay. Probably just best to like use that full build plate, because what people might not know with this technology, which is like an mSLA type technology, is it you don't get penalized for additional usage of the build plate. So if you spread parts out, you know, versus if you compare it to like an FDM 3D printer, right, where the print head has to print and then move over and then print this part, everything on the build plate on that layer is being printed at the same time with the light being flashed on it. So which is why Rob's able to load up 15 of these X-Brooks, which is, you know, a significant amount of print volume that's going on, right? So yeah, I think that's worth pointing out there. One of the huge benefits for this technology.
Yeah, as you can tell, it's a lot of information that's being put on this build plate. That's why the slicing takes a little bit longer.
Right. Let's see. Paul has a follow-up question.
Yeah.
Thanks for that question, Paul. He said along that line, can you also stack parts, for example, another layer of rooks on top?
Yeah, you actually can. Maybe I'll show you that as soon as we get this print started, because the webinar is only for, you know, about 60 minutes, and we want to get this print done in 30. Yeah. So I'm gonna get this print started, but then I can go back into NexaX and show you that feature where you actually, you can stack it on top of each other.
Totally. Yeah, and actually, if you check out our like Instagram, we just had a post up there of another part that was printed in an array on the zip that fills out the entire build volume. It was about a 3-hour print to print something like this stacked all the way up. So, you know, and it's actually, it's using a different material than Rob's using. So it's pretty cool. It just shows the speed of and throughput possibilities with zip. Let's see, looks like we've got some more questions rolling in while this slices.
Yeah, that's great, dude. I mean, I think that's the whole point. I'm here to
Yeah.
answer all of your questions, as many as I can. Yeah.
Let's see. So Ahmad was asking, is the base of this shape solid or hollow of the base of X-Rook?
The base of the X-Rook, it's solid. I've modeled in some holes actually in the bottom of it, and that was just to kind of not use as much resin on just having a solid base. I like to conserve resin wherever possible. And then with something like this, because it's completely unsupported, it just, in my opinion, it leads to a better print.
For sure. All right. Well, we got more questions, but we'll save those. We should probably get this print going, huh?
Yeah. Okay. All right. So now that I've got my print here on the USB, I'm going to take it over. You'll see the other camera, right? A little bit closer here, just so you can see kind of why interface. Over here is our USB slot. So slide that
Hey
in.
Rob. Hey Rob. Can you
Yeah.
actually can you stop sharing your screen for a sec so that we can see a bigger view of the printer as you're
Yeah,
setting?
my bad.
Cool. No problem.
All right, there it is. So there's the USB slot I was trying to show you before. Here's the UI. So, I mean, it's pretty straightforward. It's pretty easy. You're gonna hit print, go to USB, and then when you click on that file, it's gonna load in file of the printer. At the same time, I already had it loaded in, so I'm just gonna go to history. Should be able to see things.
Yeah, I think that's a really nice additional bonus feature there too. It's got your history of past prints, so you don't always have to be like searching around your computer for that print. You can also have a queue of prints, I think, showing on there if you have it network connected and have your next print ready to go in the queue once you've removed the previous print. So some nice connectivity features there.
It's just a heavy file.
Yeah.
So while this is loading that printer, oh, here we go. As soon as the job's finished loading, I'm gonna hit start, but maybe you can answer a question or two.
Yeah. Ahmad asked, does it have internal memory? I think
Yeah. That's the only way it would be able to take, to hold all the history of those different prints.
Yeah, so you can in fact remove that USB stick during the print and it will keep printing.
So total time now, it's saying it's 29 minutes. We'll hit print now. It's going to actually go through a pre-print checklist, confirm the build plate and back, print fragments. Please confirm the part volume does not exceed the maximum vat volume. Please confirm the build plate is inserted. All of that stuff is ready to go. So just confirm. And this is like a little warning. It'll tell you like if you have the wrong cartridge in compared to the vat. But since I'm not going to be using any resin from the cartridge, I'm just going to skip this. Continue. It's going to go to preparing to print. I'm going to skip that because we're not loading in the resin. Here we go.
Love that. Light flips on, build plate immediately starts dropping down into the vat.
Just got it has to be super reflective. Let me know if you guys are seeing this.
Ahmad wants to know if we can open the cover of the printer. You could do that. We probably won't because you have to there is a sensor in the door and it would pause the print if you do that. So basically the way to get around that, if you wanted to do that, you have to kind of, I think, put a magnet on there to like take it, which we do sometimes for demos. Probably should have done it this time, but oh well, hindsight's 2020, right? But you can, there is like, so that light turns off. There's a button right there where you can turn it back on just to take a peek, kind of like looking in the oven, right?
I don't know
So
if you guys can see through this. Might
yeah,
be too much reflection going on, but okay, you can see it, right?
yeah, for sure.
And it has the little light, you know, button here on the UI. You toggle that on and then the lights come on inside.
Yeah. Yeah, so cool. All right, so
All right, here we go.
I think we started about 10:20, 10:22-ish, so we'll let that go and let's talk about some of the features.
All right, so I'm going to come back over here to the computer and show you guys some more Nexa X features. So I think that's what we were asking before, was kind of like on the array, can they be kind of stacked on top of each other, right? Right. So here we are back in Nexa X. So say I wanted to stack these. I'm going to go back and just start over again, just in case anybody missed how we came up with the array. So I selected those. I'm going to delete them. Now I'm going to go to click on top view. It's just a little bit easier to kind of figure out your array that way. I'm going to click on the model. Then I'm going to go over here to the array duplication and array duplicate special. And kind of what we did before was we did 3 in the Y and space those out. So you know what? Let's just stick with 2. That way I won't have to move it around. And then the X. Okay, so I've got 5 rows. So
Hey
now,
Rob, I have a question. Were you delaying your click, or is there like a half hitch second for it to load?
it's a little bit of a delay. I'll tell
Yeah.
you why. Most times, when you're printing, you know, like a file like in STL format, even in OBJ, the vertice count on the actual file tends to be a lot lighter than these. But
Okay.
because these rooks have so much detail in them, the vertice count on them are so high. Like in ZBrush, it says that the count is about 350,000 polygons.
Wow.
But that's only like telling you about, it's only counting a face per triangle. So it's actually probably 3 times higher than that.
So this is actually a pretty intense print. So it's actually, even though the slice took a little bit longer, I've seen slicers that
Yeah,
if you print 2 or 3 like fairly simple objects, they could take like 30 minutes. So like
yeah,
it's actually pretty impressive what NextX can do with
Yeah.
like some high polygon count
yeah.
parts.
Yeah, I feel like with Nexa, I'm spoiled because I'm so used to, with other programs that I've used like Chi2 Box and things like that. And sometimes the slice can go really fast. But if you've got a slice that goes like, okay, fast in 30 seconds or something like that, but then the print is 31 hours, I'll take a half an hour print with a 1 minute or a minute and a half slice, over a 31-hour print any day.
For sure.
But yeah, so like, okay, so here's the next part though of the array. So we didn't touch on this, was going in the Z height. So if I hit that, that's when you'll see like it's gonna be on top of each other.
Can you rotate the view so we can?
Yeah, it's going right now. That's why I said it's like it's really heavy.
Yeah. Oh, there you go.
Yeah, so and that's why it took a little while too, because it didn't just do on top of each other on just one row. It did the entire 15. So that's 30 now. So if I, if I click that again, it's going to go again, the entire array up another level.
Word.
If I don't, if I don't make Nexa X crash.
Yeah, that's all right. I think we get the point. Yeah. we might be waiting a while on the supports if you try to add supports to this, but can you show us some of the other like menus like down the left side there?
Yeah, sure. Like say if I wanted to print this though with additional supports, say what I typically would do is I'm going to rotate this just slightly here. And I'm going to click out of array. And I'm going to go up to the support tab here on the left. And also another great thing about Nexa X is auto generation of supports. And not just that, but you could also make an effect to the density as well as the strength of the supports themselves. But I'm just going to hit auto generate.
Somebody asked if it would generate those auto supports between the layers when you did that Z array.
Oh yeah, yeah, big time. And for something like that with a file like this, you definitely have to do that because the rook file itself is kind of meant to just be one layer and print it with the base directly on the build plate. And that way it'll print without the need for supports. But if you're going to be doing like an array where they're going to be stacked on top of each other, it's definitely going to need some support structure. I don't know if you'd want to do that though, to be honest. With a 30-minute print, you might as well just,
right.
You can print out, four rows of them in 2 hours.
Right. All right, cool.
So here's my supports. There's also an edit feature so that you can go in and either add or remove. The cool thing though is usually when it's something like this, it's going to be like you want to remove those areas where it's just going to be like a bunch of supports together like this, where it's like, that's probably not necessary. So we have the brush tool removal and the brush radius here. You kind of get to see it. It's like it's kind of like a clear bubble. So once you click, you'll be removing whatever supports are within that bubble, and you can effect a change to the brush radius over here.
Cool.
So if I wanted to like eliminate some supports, this is kind of like, this is a more of an experience thing, like if you've printed stuff like this in the past, you kind of get a feel for, hey, it's not really going to need supports there, or not going to need supports here, or maybe there's an area where you think it might need extra supports. But once you're done with this, click on done and then apply, and it's going to go through and recalculate it.
Yeah, I think an example of when you might need that is if you had something really, really delicate maybe, and you didn't want supports touching it. I could see that being an instance, or yeah, just reducing supports in general, but
yeah,
it's a pretty powerful feature. I mean, like it's like design, like CAD features almost built right into this platform. So that's pretty impressive.
It's pretty sweet. And I mean, if you've got, this is just one example of one file. I mean, any and everybody's going to have their own different thing that they want to print. And sometimes you're going to get something that might be, it's probably not going to be as light as this, because, with the mesh, and then you see like with the holes that are on the bottom of this print, that's what kind of makes this print a bit lighter. But if you've got something that's going to be kind of heavy and you're worried about it maybe falling off of the build platform or something like that, we've got cone supports. So I'm going to click on that. And I'm going to show you what a cone support looks like. It's a big, chunky support that you can put that's going to, you know, hold that print down to the plate. But the
More
great thing
surface
about
area
this,
on the plate.
yeah. The great thing about this, though, is you can make a change to the tip radius. If it's something that's, hey, you know, I usually put it about 0.6. That gives it a little bit of you know, a smaller surface area that it actually touches the print with. And then you can change the bottom radius too, because that accounts to about 3 millimeters. So you really don't need it that thick. So usually I'll take this down to about maybe 1.6 also. You can see that cone's much different. So it's a lot. It's so much you can do with Nexa X to, you know, kind of specialize how you want that print to come out and support it.
So I think I would say with the time right now, Rob, if we could just breeze through maybe like the other menus quickly, maybe not like doing them all, but just like show what options there are, maybe some of the information you see and the tabs, and then we can move on to like some of the printer features.
Okay. Yeah. I think, well, the only other thing is like, well, there's the, you know, the edit. So in edit, you'll be able to do things like if you bring in a model and it says that it's, you know, something needs to be repaired on it, you'll be able to do that, hollow out. You'll be able to also use a perforation tool. And, you know, everyone, I think, kind of understands how these things work. Depending on what model you have, sometimes you have to hollow things out, or you might have to poke a hole in a certain part just so that resin doesn't get trapped in there during the build process. And that's stuff that you can kind of see when you go through with the slicer here. So you'll be able to see if there's any problem areas and things that you need to make adjustments with. So that's just a breeze through, I guess, of the edit feature here. We kind of went into analyze already, where you can measure things out. Save, of course, you know, there's two different types of saves we have. We have a save scene and we've got save job. Now you notice like that previous file, it said it was too large because it was so many of these on the plate. But if I click on save scene now, and I'll just name it really quickly, X45 natural test 2. It'll save that.
So like for those who might not know, the difference between a scene and a job. So a scene would be like something that can you like where you open it back up and you can edit it again, and a job is like a slice that's ready for the printer. Is that the difference?
Yeah, as a matter of fact, I can show you, and this is one of the greatest things that I especially appreciate about Nexa X, is you can open up a new tab. So you can work on a different print. Like say if I wanted to work on another print in a different resin material. So I'll take ABS, for example. ABS has a layer height of 100 micron natively. There's some advanced settings that you can toggle here as far as if you want to increase base exposure. The wait time that directly translates to how much time the print will wait before it flashes a new layer. So with some of the more viscous resin or resin that's stickier, you might want to increase the wait time, but you have the option to do that. And because, you know, the XiP is such an open platform, having the ability to kind of toggle all of these things is just, it's phenomenal. Also with the base layer, you'll notice you can change how many base layers you want to put for each of the models that you bring in. Also, you can change the base exposure time and the just normal exposure time for the entire print. I'm just going to click on apply. And so now I have a new tab here with new settings for a new resin. And what I'm going to do is import, like instead of importing the model, I'm going to import a scene. So I'm going to click on load scene. That's going to bring me back to this. Here, I'll show you like a little fun thing that I was working on. Oh no, wait, that was too, well, maybe not, because that was kind of high, but let's see. Where are you?
We can't. I think you're scrolling through a
There we go.
menu, right? We can't see that on the screen, so it's not frozen. Rob was just going through a pop-up window that didn't show up on the screen.
Yeah. All right. Well, this actually is a scene that was for the NXC. I'm gonna bring it in anyway, just to show you how much you can do with, even if you have this, you know, in an industrial setting, and say you're working with the NXC 400s also in tandem with your ZiP, you'll be able to bring in one of those files, and you see how it adjusts the size of the print. Like, this is a forearm that I was printing out for the NXC 400. But because Nexa X has these tabs, I can toggle through, and here I am back to the zip file with a completely different build aspect ratio. And if I wanted to, I could open up another tab even. So it's just great to be able to do that.
Yeah, I was just gonna ask the stuff on the right side there.
All right, yeah. So job info over here. It's kind of hard to see just because the zoom window, my zoom window is over here. I'm gonna move that over just a little bit. Okay, so job info settings. This tells you what printer you're using, the resin, and the layer thickness. So if I wanted to switch that, say I'll put this in a material that I know is that I have also on the ZiP. Gotta go to ABS. ZiP, hit apply. All right, so now it's gonna bring that down to the ZiP size. And it's gonna be an ABS resin. Okay, so your details tabs, that's gonna tell you how many layers is in the print. The volume is gonna tell you how much resin is gonna be used for that print, and then the print time. So something like this, where it's almost like the entire build volume in the Z height for the ZiP, is gonna be about 12 hours in this resin. Now, if I switch to a different resin, you're gonna get a different readout. It's gonna also switch to layer height. So if I hit apply, so printing something big out like this in almost the entire Z height, it's gonna take about an hour and a half.
Cool. Yeah, really nice to have the option to like do very quick prototypes like in an hour and a half, or if you want something in performance resin, an ABS like resin, like still only 12 hours. I mean, that print on like a lot of printers I know, SLA printer or FDM printers that are very popular in the space, like professional level printers. I mean, you're talking about potentially, 24, 48 hours, several days for something that's like the full, because ZiP actually has a pretty big build volume when you think of desktop 3D printers. So
yeah, it's amazing to think, something like this is something, like with an SLA printer that I've worked with in the past. This is like an overnight print. This is something like, hey, I'm putting this on at the end of the day and come back tomorrow, and maybe it'll be finished by the morning,
maybe
something like that. Yeah,
I would say this one, and in a performance material too, like you're probably talking, I mean, a little bit longer, but all right. So I think we pretty much covered everything in Nexa X. If you're good, maybe let's move over to the printer with like the next 10 minutes as the print's kind of wrapping up there. And then we also have like maybe 15 more questions to get to.
Yeah, sure.
So let's go through like, I think we've got like 8 features we want to cover here specifically to call out.
Yeah. Well, you know what? Because we're in our little demo showroom, there's kind of like a lot to show and tell. Here, I grabbed
Yeah.
an extra build plate just so we can kind of see like just the build volume, the area that you're gonna have for the plate. I mean, it's pretty, hefty plate for a desktop printer this size. So we got that. We've got the
vat itself. So the great thing about this printer, it's like this vat is stuck in there. It's not going anywhere because it's locked in with electromagnets. See, it says engaged here. I have to click on that, disengage. But this is our vat. And this is pretty much the secret sauce of why this printer is so fast. This membrane that's used here, it's LSPc, because that's the name of the technology that we use. Basically, what that means is that it's lubricated on both sides. So during the peel process, it makes it super fast to peel from this membrane. But the great thing too about this is, with a lot of different other, maybe resin printers that you use, having to replace the film on the bottom of these things is a nightmare. It's like you can set aside 35 minutes just on its own, just trying to replace the film. But this has kind of like a quick release. There's 8 tabs on the bottom. So you can just pluck the membrane out, switch that out. Again, it has a little gasket here at the top. So when you're putting that back in, that familiar drum sound. But you use the tabs here to lock it in place.
Yeah, and just to expand on that a little bit, the LSPc technology, which stands for lubricated sublayer photo curing, is a proprietary Nexa 3D technology. It was developed for our $60,000 NXE 400 printers. So, if you're not familiar with those, like the comp, it would basically be the carbon 3D printers that everybody's probably pretty aware of in the industry. Although those ones are, I would say, much more affordable than the carbon ones, but bigger build volume, whatever. It's an ultra fast 3D printer. So this is actually a technology that doesn't exist in any other shape or form currently at the desktop level. And that's what makes, I think, XiP such a game changer. So, we're talking about speed. It's like, it's faster. It's easily faster than FDM and SLA, but also like any other mSLA printers, because of that barrier and some of the other, proprietary light engine features. It just kind of blows the doors off other printers. So that's kind of.
I don't know if you guys been forgetting this. But that's locked in there. The vat's not going anywhere. I just love
Yeah.
that thing.
Yeah. All right. So that's kind of LSPc technology. What do you got next, Rob?
Yeah, this is the resin cartridge that we have. These are made of aluminum. The great thing about that is I remember just being in, again, using a lot of different resin printers and things like that. Usually you'll get a cartridge. It's all plastic. And the thing about that is it's cheaper to make, it's lightweight, but you have to throw the entire thing out. So it's super wasteful. So with something like this, it's aluminum so that you can refill this. You can, makes it a little bit more durable too. Especially like if you look at the entire machine, it's aluminum. And that helps this thing print at the same time, repeatable over and over again.
Right. Yeah. And aluminum's one of the most recyclable materials in the world. So that helps too. So, I mean, XiP was, I think it is definitely a very sustainable design in both the printer and the cartridges, which is cool.
Yeah, it's something like, I think the percentage is about 97% recyclable.
Yeah.
Aluminum. So
speaking of, I guess, resin, open materials that we have, you want to touch on some of that stuff?
yeah. The resin materials that we have, particularly, here with at Nexa, have been phenomenal. I know a lot of times you'll hear like, hey, this resin or that resin is ABS-like, or it mimics polypropylene, or rubber in some respects. But the materials that we have here, I'll show you. This is one print that we had at Rapid TCT in Detroit. This was a part of a huge helmet that we built called an excavator. This is an ABS material. So, a lot of times with something like this, people just say they're ABS, but like, can they do this? And it's for the prop industry, which I'm in, it's super great because something like this you can paint and you can see like how that really looks like metal.
Yeah.
And
A Rob Wiggins original design, by the way.
so yeah, over the place. There you go.
Yeah. Yeah, I mean, so, and just to add to that, XABS, obviously ABS, one of the most, popular consumer products, materials, injection molding, and all of that. We've got XPeak, which is a peak analog. It can get up to like 230 degrees Celsius under pressure. That's a heat deflection temp. So really useful for like tooling applications where you're actually printing the molds out and doing tooling with those molds. We've got a PP analog, XP polypropylene, and a whole bunch of different high-speed modeling materials. So, and then there's X Flex, which is actually one of my favorites. I don't know if you have an example of X Flex there, but it's like a Shore 55 silicon-like material, very flexible, tear resistant kind of material.
Yeah, well, you know what? The cool thing about this X-Work that we created, we did create one in X-Flex too. So you'll be able to actually check that out on our website, and you can order a sample for yourself.
Oh yeah,
in that flex material. So that's
which reminds me, I will drop that link into the chat right now. Going live this second, first time in the wild that you can go and order your X-Rook sample if you want to check out these parts for yourself.
Yeah. So this here is the light engine, and I wanted to show you this. Is like, why are they showing the light engine? Well, you see how kind of like replaceable this piece is, which speaks to the modularity of this printer. A lot of times, replacing actual like the light, the LCD or something like that on a printer is like another laborious task, where it's like, okay, set aside an hour to rewire the thing. You have to like put tape down over the edges or something like that when you're using mSLA, or even if you're using SLA and you have to take out an entire light unit. That's a task. Whereas with this, it's basically 4 screws that you're going to take out and then pop it out, pop a new one in. You have to replace the light source.
Easy peasy. How's our print coming along there?
See, it's got 1 minute remaining.
All right, cool. Let's keep
good. I don't want. You know what? I just want to let it cook. Just let it come out in a minute, and then I'll show you. I would turn the light on so you can take a look at it, but I think you're gonna like this.
All right, cool. All right. Couple other quick features. We talked about the swappable vat, the sustainable build. We talked a little bit about the connectivity. So while Rob wasn't connected to that printer, yes, if you can connect to printers on the same network via Wi-Fi, Ethernet, and of course just use a USB thumb drive. So a bunch of options there. And actually within Nexa X, you can manage like your fleet of printers, so you can see all the ones that are on your network you're connected to, and send different prints. Say you have like 3 printers with different materials, you can have options available for you and the rest of your team, which is really cool. And then yeah, oh yeah,
just in preparation. There it goes.
I see a smiley face. All right, sweet.
Guys, you ready?
Yeah, let's do it. Sweet. All right, so 10:51 I've got. So yeah, it was 29 minutes, just like it said on the print preview.
Yeah. I don't want to take it out because it's like gonna drip all over the place. And I don't have a tray with me, but
Yeah, that is crucial. You wanna get like a nice like lunch tray or something that you can kind of put that build plate right onto when you go to bring it to the wash.
yeah, I did a test print of this earlier. Just to make sure like, hey, using the same resin settings and all that stuff. So, but the print will ask you, I'll show you on the UI. It's gonna ask you was print successful? Yes, and that gets kind of like logged into the history of the printer. But I think I have an X-work over here. This was one of the test prints we ran earlier.
Yeah, really nice. So that is what is that material that you printed in?
This is the X45 Natural. It's our fastest material.
Okay.
Kind of hard to sometimes with the camera to get it in focus.
Yeah. Looks like some people are having some issues with that XRIC link. That's okay. We'll get that fixed up, and honestly, we're gonna send an email out either today or tomorrow, maybe early next week, reminding about XRIC when it to the general public. So even though you guys got a little sneak peek of that, it will be up and running and orderable very shortly. So
So it made its debut today.
yeah, cool. I think I guess the only things you already showed the touchscreen. So touchscreen, we both talk about the responsiveness of that, which seems like a little thing, but is that attention to detail that you get?
Oh yeah, it's this touchscreen, it's so different from the other ones that I've used, especially the thing that you'll see how sensitive it is. I'm just going to take you to like connection. So here,
Oh,
let's see a little better. So here on
yep, we see it.
Wi-Fi or Ethernet. Wi-Fi. Now the big thing is, like a lot of times when you're going to Wi-Fi network and you want to log in, it's crucial how sensitive basically the screen is. And it's just like, it's so cool that this thing is, I know it seems nerdy, but it's like coming from like other touchscreens where you're like input.
It's a huge.
It's definitely like, it's a joy basically dealing with this rather than having to go, use other touchscreens.
Yeah. I think it all just kind of goes back into that build quality, and the attention to detail on this printer. So nothing was really overlooked. So all right, so we got a bunch of questions. I'm gonna go ahead and start answering some of those, but I'm gonna throw this up on the screen really quickly. All right, so let's see. Ahmad, thanks for all your questions, man. Is XiP the same speed as other industrial models like the NXE 400? It is pretty much the same technology, although NXE 400 is going to be a larger build volume just because it's built for. Rob, you've got an NXE 400 probably right next to you there. Maybe you could turn. I don't know if you could turn your phone to like show the audience like how big that thing is. Like, not a desktop printer. So
this is by no means a desktop printer.
Those are the NXE 400s.
Here, can you see it?
Yep. Yeah, let me just actually.
Actually, guys, you know what? Let me bring over
So I think to answer the question is I would say it's almost as fast. That XC, it's got a little bit more beefier, I think laser or not laser, maybe light engine thermal management, I think is another thing. It's just got more heat sinks and coolers. So, it can go actually even a little bit faster. I think it is probably the fastest or one of the fastest industrial printers. So, ZiP is definitely the fastest desktop 3D printer available. Cool. Yeah, there you go. Yeah. Let's see. Let me go through some more questions here for us, Rob. This model is an LCD screen or UV light plus LCD.
I think it's UV light plus LCD.
Yeah.
It's an array underneath the LCD that's going to make sure that the light is perfectly perpendicular.
Yeah.
When it's coming out.
And it's got an array of columnar lenses, so it gets better focus to that going through that LCD. It's a 4K LCD, and it's got anti-aliasing technology too, which enables actually sub-pixel resolution. So that's kind of a cool bonus too.
Right. That's why we can print at 0.52 micron size on this.
Totally. All right. Oh, okay. Let's see. Are you able to configure the tabs or bridges between the vertical parts?
Are you talking about within Nexa X? Are we able to?
Yeah, I think so. Yeah.
And get that question again. I kind of quite didn't understand.
I guess, are you able to configure the bridges between vertical parts? So we're talking about bridging.
Oh, like kind of like what we.
Or no, you know what? I think he's talking about supports. Now that I think about it, because we were doing the vertical stacking. So
Okay.
I think we already said, yeah, you can do that.
Right.
Are we watching the basic software or the pro version? What were you using?
I'm using actually an internal version, but the internal version that I'm using is going to be pretty much the same as the pro version.
Yeah,
so that's why
I think I have the. Is that the? But I guess the question is that's the free version? Like that is actually the free version. The pro version has additional. Or I guess the free version has like all of the base resins, right? The pro version allows for additional open materials and stuff like that, right?
Yeah.
So
yeah,
it's like more experimentation with like different resins and details and stuff you need to try out.
right. Yeah, I mean, you can pretty much use, because it's such an open system, you'll be able to use any resin that's going to be in the 405 wavelength.
Yeah. Casper asked, is ZiP readily available or is there a waiting list? It is actually shipping. We started shipping them in June, so they're already in customers' hands. You can actually order. We do have this upgrade promo that I'm showing on the screen with this QR code. So if you actually have a printer already at home or at work, you can get up to $1,000 off ZiP. Or you can just go to nexa3d.com/zip and check out the printer, and you can place your order right now online. So
yeah.
When is the Mac OS version of Nexa X going to be available? That's
Sean can speak to that directly, right, Sean?
A relevant question. I actually have a Mac that I'm on right now, and I actually just got a version of it. So I'm told any day now it should be going live. So yeah, it's worked perfectly for me. So yeah, it looks just like what Rob presented here on his PC. Works really well. So
yeah, you Mac people are spoiled, man. You guys get everything at first, usually. So.
Not this time.
Yeah, just this one time.
Yeah, but yeah, no, coming very soon. So yeah, I think that about does it. We're pretty much out of time here. So want to thank everybody for hopping on with us today. I think we're going to be doing more of these. Let us know if you liked this in the chat, and if you want to see more of these kind of demos. Maybe we'll do some with the NXE 400 too. And you know, Rob is a great person to do these because he knows, he's been printing with this printer for a while now. So yeah, and
I'm happy to do it.
thanks Rob for hopping on.
Man, thank you for having me. I'm happy to do this too. It's like, you know, we got to prove it, right?
Exactly. It's, you can say, everybody says everything's fast in 3D printing. I've been in this industry for eight plus years now. But I came to this company because this is amazingly fast. I always say it's eye-wateringly fast. So you know, there's really no comparison right now in the space. So.
I love it. Yeah, eye-wateringly fast is precise. I love it.
Yeah, so cool, guys. Well, yeah, again, thanks everybody, and until next time, we'll see you later, and happy printing.
Ciao.